Plotting points in polar coordinates. Normally when we plot points or draw graphs, we like to have a piece of graph paper. But standard graph paper is not really very useful when you're dealing with polar coordinates. This kind of graph paper is full of horizontal and vertical lines because I'm always traveling left, right, up, or down. But in polar coordinates, that's not really what I'm doing. So this kind of graph paper is not really going to be very helpful to us. What I need is what's called polar graph paper. And I've given you a sample right here. You can see it's organized a little bit differently than what we're used to. Around the edge, I have different angles because I'm going to have to rotate some certain amount. This particular graph paper counts by pi over 12, which is 15 degrees. So every 15 degrees is marked out right here on the paper. And then the distances that I travel in polar coordinates are not horizontal and vertical typically. They're often diagonal. And so you can see along each angle, the concentric circles mark out 1 step, 2 steps, 3 steps, 4 steps. This one goes all the way out to 5, to a distance of 5. And so that helps me to accurately plot the points that I'm working with. Now, this first example says plot the point 3 comma pi over 4. Remember, r comes first in polar coordinates, followed by theta. This is telling me start at the origin. Remember, you're always facing the positive x-axis at the start. You're going to rotate in the amount that theta tells you. Positive thetas mean rotate around counterclockwise, just like what we're used to. So I will rotate from here until I get to pi over 4. You can see it here, right, on the edge. And then along that pi over 4 line, you can imagine me standing here facing that pi over 4. I am going to walk 3 units. 1, 2, 3 units out. Here's the place I will put my dot. I have rotated pi over 4 and walked 3 units out. So now that we have it, what are some other names for that same point? Really what we're asking is, what are some other ways somebody could have gotten there other than the way we did it? I suppose the simplest answer is we could have worked in degrees instead of radians. So 3 comma 45 degrees is certainly the same thing. But a more interesting answer would be we could have rotated around more than once. We could have spun around more than once and then went an extra pi over 4 more, an extra 45 degrees, and then walked our 3 units. So we still would have walked 3 units, but this would be spinning around 9 pi over 4. 2 pi plus an extra pi over 4, 8 pi over 4 plus pi over 4 is 9 pi over 4. So that's another way that I could have gotten to that same spot. What about the whole walk backward thing? Well, what you would have to do is you'd have to figure out what direction I would need to be facing so that if I walked backward, I would land at my blue dot. And of course, it's just going to be exactly halfway around the circle, exactly 180 degrees on the other side, or pi radians on the other side. So what I could have done is I could have rotated around until I got to here. How much is that? That's 5 pi over 4. So I could have rotated around 5 pi over 4. The angle goes second. And if I was standing at 0, 0, facing the 5 pi over 4, but then I walked backwards 1, 2, 3 units, I'd land at the same spot. Backwards is a negative r, so negative 3 comma 5 pi over 4. What if I wanted to use a negative angle? What if I wanted to rotate around clockwise? I'm at the positive x-axis. I could rotate around clockwise until I got to that 5 pi over 4 spot. Now I'd have to think for a second, how far did I rotate then? Wouldn't that be 45 degrees past 90? So negative 135 degrees, I think is what that is. In radians, that would be negative 3 pi over 4. Now if I stopped rotating there, I'd be facing this direction again, so I'd have to walk backward 3 spaces to get myself to that same spot. And obviously there are other options as well. We could have rotated clockwise all the way to here so that I could have walked forward 3 spaces. Or we could have gone around more than once like we talked about before. Because of all the coterminal angles, there are an infinite number of names for each polar coordinate point. Okay, let's try a couple other ones. We want to plot the point -4 comma pi over 2. So r and theta, I start at the origin, I'm facing the positive x-axis, I'm going to rotate around, let's see, pi over 2 is positive, so I'll rotate counterclockwise. I'm now facing the pi over 2, and so standing at the origin, looking up at that pi over 2, am I going to start walking toward it? No, I'm not, because my r value is negative, so I'm going to start walking away from it. I'm going to walk backwards 1, 2, 3, 4 spaces. Here would be the point -4 comma pi over 2. What would be some other names for that point? Well, if I had wanted to walk forward 4 spaces, then I would have had to rotate all the way around to the 270-degree mark, or the 3 pi over 2 mark. And then I would have been facing the correct direction. I could have just walked forward 4 spaces. Another option, I could have rotated in a negative direction. So negative 90 degrees, that also would have meant I was facing the right direction, so I could have walked forward 4 steps if I had rotated negative pi over 2 or negative 90 degrees. You can come up with more examples if you like. The final example says plot the point 2 comma negative 210 degrees. Again, here's my r and here's my theta. Now obviously my polar graph paper is set up in radians, so I'll have to do some thinking here. I'm going to start at the origin. I'm facing the positive x-axis. I am going to rotate around clockwise because of the negative. Let's see, how far am I going to end up? 210 degrees, that's 7 pi over 6. Just be careful though. You're not going to end up here. The numbers that are marked around the edge, these are the positive angles only. You're not being shown the negative angles. So you're going to have to do some thinking here. If I'm going to rotate -210, I mean, that's past 180, right? I know I'm going past 180 another 30 degrees. So I'm going to end up here. I'm going to end up facing this direction. Rotating -7 pi over 6 takes me to the same spot as rotating +5 pi over 6. In any case, let's plot our point now. We are aimed in the right direction. Our r value is positive, so I need to step out 2 spaces in that direction, and here would be the point right there. What would be some other names for this particular point? Well, as we just said, I could have rotated in a positive direction 5 pi over 6 and then walked 2 steps forward, so that certainly would have worked. How could I have walked 2 steps backwards? Well, in order to do that, I would have had to rotate exactly to the opposite side of the circle. Sometimes it's helpful to draw it in. That would be that spot right there. So I could have rotated just this amount. How far is that? Remember, the scale goes by 15 degrees. I've gone 2 angle markings here. So I've gone 30 degrees in a negative direction. That's -30 degrees, or negative pi over 6 in radians. If I rotated there, faced this direction, but then walked backwards 2 spaces, I'd end up at the same spot. And of course, there are many other names you could write down as well. Thanks for watching.